Right. So today we'll be looking at the intuitive approach to differentiation using limits. First of all, what is limits? Nicholas, you probably at your limit. Are you?
ACCX close AI pass my limit.
Right. So what is limits? Limits is when we look at what happens right before bacchanal. That's what it is. Imagine you had a function like y is equal to 5 over x. Um, Nicholas, at what value for x is the function invalid?
Um, five,
Say that again?
five,
5, but 5 over 5 is 1. That makes sense. We can do that.
and then six.
Amy, he's saying that 6 makes the function undefined. Is that true?
No.
Nicholas, if I plug 6 into this function, what will I end up with?
Wait. Oh, alright.
Oh, I end up
Five
with
over
5.
six.
That, and that's a number, right? So that's
Yes.
that's that's valid. That's a number.
What then?
What value of x would make this function blow up like a terrorist? What,
Sorry.
yeah, what value for x would make this equation blow up?
Um, that'll be bigger or smaller.
It's what I'm saying, right? Um, Once it's a number and I can put it into the function and get another number, it does fine. So you could tell me a million. You could tell me -5. You could tell me -20. You could tell me any number really, except for one number. Have one number that does make this function go crazy. Just don't work.
3.14.
This man call out pi. Oh nah, no. Like I told you, if you put 5 over 3.14, and you still gonna get something in the calculator,
Yeah.
will the calculator say error?
Now
No, let me understand how division does work, right? If I say 5 over 1, what does that mean?
that means just five.
And why I say that? That's because how much ones would it take to make 5?
Five.
Okay. If I have 5 over 2.5 now, how much 2.5 is it going to take to make 5? How much?
Two.
2. How much 5 is it going to take to make 5?
One.
Okay. Amy, hit him with it now. 5 over what?
0.
Ask him, Amy. Ask him.
Wait. Oh, how much zeros does it take to make 5?
That's a good question.
Ah, tell me. Plug it into your calculator. See if it give you a number.
Five. Five over zero. Math error.
Boom, it blew up. Right. Because tell me, how much zeros it would take to make 5?
Much zeros it take to make five?
Yeah, you tell me. That possible?
Cannot, you cannot make five with zero.
Ah. So then that makes the function undefined. You should probably make a note about that, eh? If you ever get a question and they ask you to to state the value of x where the function is undefined, Nicholas here, no? If
Yeah,
they will ask this in maths and hard maths. If they ever ask for that, you're looking for the value of x in the denominator that would that would make it 0. So let me give you an example, right? What if we had a function y is equal to 9 over x plus 3? What value of x would make this function blow up?
um, -3.
Yeah, -3. Correct. Because -3 plus 3 is 0, and no amount of zeros will ever make up $9. Right. See, you're thinking, you understand that? Let me show
Yeah.
you, let me show you a graph now. You know what's an asymptote?
Nah.
Again, it don't have anything to do with total, eh? It don't have anything to do with total.
Yeah.
All right. It's a recording, otherwise I'd ask you something, Nicholas.
Yeah.
I don't,
Alright.
I don't think it's kind of tough these days. After what happened on Instagram and thing, boy. Ooh.
Well,
All right. All right. So that's the y-axis, that's the x-axis. Now, this function, right? It look like it's approaching what? How does it look like it's approaching?
um approaching the y-axis.
Give me a number. Do you think that this will ever touch the y-axis?
Will look so.
It will never touch the y-axis. Now, this graph here is not the exact graph for this, but we're just saying it is for explanation's sake. Just for explanation. So let me see what happens as x gets smaller and smaller and smaller. So when x is equal to 1, what is y equal to? It's 5 over 1.
5 over 1 is 5.
Oh, I was asking what x is. Okay, x is equal to 5. What x is equal to 5 will be equal to.
5 is equal to 1.
All right, what about x is equal to 1 over 2? So here we're asking you, right? How much 5 over a half? How much halves it go take to make 5?
10.
It go take 10. Okay. How much a quarter is it go take to make 5?
20.
What you noticing about x? Again, smaller or bigger?
Smaller.
And what you noticing about y? Again, smaller or bigger?
Bigger.
Okay. Let me go somewhere far. What about x over 100? How much 1 over 100 you go take to make 5?
5. Just now. 500.
So imagine if you had, wait, which 1 over 100 is a decimal? That is 0.01. So Nicholas, imagine if you had 1 cent and you were saving 1 cent every day. How much days it go take it to make $5?
And every day.
Every day,
500 days.
500 days. Boy. Hmm.
Huh.
So the smaller the fraction gets, the more of it you would need to make up the whole number, right? Some of that making sense.
Yeah, it makes sense.
So if you were saving 25 cents a day, it could take you 20 days, right? If you're saving 50 cents a day, how much it would take? How much days it would take?
10 days.
All right. We're going good. What if you were saving, I don't know, this is like this it even have sense that this small. If you were saving one thousandths, one thousandths is 0.001. That is a tenth of a cent. If you were saving a tenth of a cent, how much days it would take you to make $5?
5,000.
All right. And lastly, okay, so I'm asking a question, right? The smaller x gets, the y value gets bigger, right?
Yeah.
So when x gets, so x is approaching what then? What is x approaching?
Approaching 0.
Approaching 0. But what we know happens at 0. The function is,
Function is
the function is undefined. Say it, undefined, undefined.
defined. I was trying to remember the word.
What is undefined, right? So And that brings me to this question. If you were saving $0 a day, you'd never make $5. That's the best way I could think about it. If you was making $0 a day and you would never save $5.
Yeah.
But if you were saving 1 millionth of a cent a day, and you would eventually get five, like how much years later,
Eventually.
you'll be
Yeah.
dead. You'll be dead. But eventually. So what I want you to take away from this is as x approaches zero, y tends to
It's
think about it. The number's getting,
bigger.
so it would tend to. That's what I.
Um,
That's what I.
increase.
Nah, it wouldn't tend to increase. That's true, but I'm looking for a specific word. It tends to what? There's there's no limit for how small the fraction could get, you know. The fraction could be 1/1 billion, 1/1 quadrillion. And why would just keep on getting bigger? Why would just keep on getting bigger? So that's what I. Buzz Lightyear to say
Infinite.
infinity.
Yeah.
So as x approaches zero, y tends to
Y tends to infinity.
yes.
I don't think, well, I wasn't thinking that was making any sense.
Yes.
Come, come on.
And it does make sense grammatically. If x approaches zero, y tends to infinity. That's the correct mathematical term. I'm not speaking nonsense here. That's the correct. If you go in a textbook, you'll see that. And you can see it on the graph. Watch. If this is 1 over here, you'll have a value here. What about if I take a value over here? That'll be like 0 point something. And y looking much bigger.
Yeah.
But I want you to notice something. Does it ever approach zero? Like, does it ever reach? I mean, it's approaching zero, but does it reach zero?
Ah,
No, but it wants to, but it can't. And if I just continue drawing this graph, the y value gonna approach? You could see it now. The y value gonna approach.
which
Listen,
means the approach
it's approaching what?
zero.
No, it's approaching infinity. It is approaching zero, right? It is approaching zero, but I was talking about the y value. It would as x gets smaller, the y value
Infinity.
it gets bigger, right?
Yeah.
Because you will need to save more days to make the same money, right?
Yeah.
So as it gets smaller and smaller and smaller, this goes up, 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 up. So say it one more time. As x approaches zero, y tends to
Infinity.
yeah, that's it. That's limits. So in limits, what we just look at the pattern like right before chaos. So I'll make this note a little neat and allow you all to copy it down. I see Aliyah join. Aliyah, you missed out. I don't know how you joined so late, but pressure because we're gonna be doing this today. Aliyah, Mr. Ramlakan,
Yeah, I hear. Sorry.
what going on? I see you join real late.
Yeah.
How is that so?
My laptop is giving trouble too. So
And when did you try to start up your laptop? What time?
before 10.
What time before 10? Like 10 minutes before 10?
Yeah, like 10 minutes before.
Probably do it a little before, like 30 minutes. If you know the laptop is give trouble.
Mm-hmm.
Right? I'll explain back the concept here after I neaten up the notes. So tell you all when to copy this on. The mathematical notation for this is limit as x 0. So, Nicholas, you see all of this writing I do here?
Yeah.
Yeah, you don't have to write any of that. You could jump straight to this. Like that's all you gotta write. You gotta write limit as x approaches 0 for 5 over x is positive infinity. Because we know that
Alright.
and we know that will happen because
Yeah.
as x gets smaller in this function, it will take more days to make $5. So eventually it will take you like an infinite amount of days to make five. Like it will take you so long now. It will be senseless.
Yeah.
Yeah. Amy, you real good, right? Like this making perfect sense to you.
Yeah, I understand everything.
Nice. I feel like that money analogy was real good. I was real good because it makes sense. If you're saving $0 a day, no amount of days could pass by where you gonna make five. Hence,
Yeah.
I'm gonna get the actual graph for 5 over x because that graph there looking like e to the x over ln x. It written by you all?
Yeah, during the real hot.
Written is the
Yeah,
best.
I need to.
Yeah, me too.
Are they like sun more or rain more? Which one?
Rain.
Yeah, rain is the best. For sure. Right, so this is actually what the graph looks like. Right, and can anybody tell me what the name of this is? When a graph is approaching one of the axes, but it never quite reaches. What do you call that? That's with A. This is an example of a Nicholas. It sound like a totem.
Asymptote.
Right. I read. It's a real weird spelling. Let me make sure I spell it correctly. Right. You see, you have the word totem in it. But are we totem?
Never.
Never. Right. So we're dealing with limits here. Right. When taking limits, we look at the behavior right before chaos. Nicholas, what is the note again? What does it mean? At what value of x is a function undefined? Note.
Yeah.
Right? So a function is undefined. Well, not all the time. Let me just say the correct thing. It's undefined when the denominator is equal to 0. It's undefined when the denominator. So yeah, this is stuff that's fairly easy to understand. You'll understand it in no time. Don't worry. All right, Nicholas, you can see that to copy down, or like it's too small.
I think you had to zoom in a little more.
Hmm. See if I could fit everything. You're on a phone or a laptop?
Laptop.
Okay. So then anybody on their phone is real bad. It's still real bad.
Nah, it's better.
Okay. Right. So Aliyah, you there?
Yeah.
All right. So Aliyah, let me just say you was trying to save $5, right?
Mm-hmm.
You have a big fete to go to and you're trying to save $5, right? A young brother in that fete on $5. Right. If you're saving $1 a day, how much days it go take to make the $5?
5.
Okay, if you were saving, it would just be rich, right? Real rich. You're getting $5 a day. How much days it go take to make that $5?
1.
Okay, cool. Let me just say you're saving 50 cents a day. How much it go take to make five?
What was that?
Let me just say you're saving 50 cents every day. 50 cents every day. How much days it go take?
10 days?
10 days. Let me just say you was saving 25 cents every day. How much days it go take?
Um, wait, 5? No.
No.
Wait, hold on.
So if you want to figure out this, you could use division. So we have a function here, and the function is y is equal to 5 over x, which is the equation for what we're trying to discuss here. So 5 is the amount of money you're trying to save, and we're trying to figure out how much days it will take, so we divide it. So you can put 5 over a quarter in the calculator.
20.
20. Let me just say it was saving 1 cent every day. Things are real bad. 1 cent every day. How much days it will take to make $5?
Like 500.
500. Let me just say it was saving like 1,000. How much days it would take to save up that $5?
5,000.
So let me ask you a question. The less money you're making,
The more days it takes to
right?
make the amount.
Yes. And in maths, we described as division. So I have 5 over x. X is the amount of money you're saving in 1 day. So as x gets smaller, what happens to y?
It increases.
Okay. And x is approaching what value?
The zero value. Well,
Right.
zero.
Yeah. And y is just getting bigger and bigger and bigger. But let me ask that question. What happens when you're saving $0 a day?
You wouldn't get the 5.
You wouldn't get a 5. So you had to look at what happens right before. So in limits, you're looking at the behavior right before. So like right before zero is like 1/1 billion or something. Not even that, like 1/quadrillion. You see, the thing is the fraction could just keep on getting smaller and smaller. But at least it's getting closer and closer to zero.
Yeah.
But if you were saving 1 billionth every day, it could take you 5 billion days to make that $5. So ends the amount of days approaching infinity.
Yeah.
Right. So this is basic concept. As x approaches zero, y gets larger, so it tends to infinity. And you can see it on the graph, right? Um, let me just say over here, x is 1, right? X is 1 over here.
Mm-hmm.
You have a smallish value. Over here, x could be what? We're not looking like x is
0.
no, x is 0 is over here.
Wait, what you say 1? So
All
that's
right.
like
So
point
what
five.
is yeah, that'll be 0.5. And at 0.5, would the y value be smaller or bigger?
It would be bigger.
Bigger. This graph here is the same graph for this function. So it'll be
Mm-hmm.
bigger. What if what if it was like what if it was like 1/10 now? It bigger.
Yeah.
Wha- And a way to observe something, isn't it like you're getting real close to zero?
Mm-hmm.
But it will never reach zero because remind me, if you're saving $0 a day, you ever get
Yeah.
$5?
Yeah. No.
No. So it approaching infinity. That's why you see it getting closer and closer, but it will never reach the y-axis. The value will approach infinity. So you understand
Mm-hmm.
limits?
Yeah.
Nice. And in maths, we note the notation for it is this. So you would say limit as x approaches zero for the function is equal. Well, this one will be positive infinity. You just had to write this. You know how to write this. So Aliyah, you don't know how to do any of this. This happens in your head. We understand this.
Yeah.
So let me give you all a couple of questions. Um, find the limits of the following. Now, this is really a pure maths topic, but CXC decided to squeeze it in and add maths. But right now, that's hard. I feel like if this wasn't hard maths, I would be fine with it. If this was like a big topic in hard maths, it would not be hard. So find the limits for question one. Let me just say we have a function f of x is equal to 9x. Right, so as soon as you'll have the limits copy down, the notes for that copy down, you can start the question. Email me share hack.
Sure.
For most instances, you can just plug in the value. Like in question three, I mean, you can just plug in x to 0. For question one, it really depends. If it's a fraction, you have to be careful, but in most instances, you can just plug in whatever you're approaching. Yeah, like 5 over x, we can just plug in 0 into that. And well, we know what will happen. If the value for x gets smaller as it approaches 0, it'll get bigger. So 5 over x is infinity. When you do the questions, you go understand. But try 1, 2, and 3. Nicholas, Aliyah, I want you all to try 1, 2, and 3. My hint is, or you could just plug it in for the most part. Hey, Nicholas, you good at factorizing?
Factorizing.
Yeah.
How, kinda.
Okay, because you gotta use it in the harder questions for limits. Um, Nicholas, the first question, right? If x approaches 0, so x approaches 0, what would the answer be?
If x approaches 0, it'll be 9 by 0,
Yeah. So that'll just be what?
0,
Right. What if x approaches infinity? Think about it. 9 by infinity. That just,
infinity.
yeah. Positive infinity. Alia, you finished copying down everything? The notes for limits?
Yeah. I doing
Okay.
the questions.
All right, nice. Nicholas, you there?
Yeah.
All right. So limit as x approaches zero. As x approaches zero, right? Um, think of 9 by 0. What's 9 by 0?
Yeah.
I see what positive infinity.
That's what's the left hand side, the equation on the left hand side.
Hmm. All right. This is we doing the limits here. It's a different kind of equation, is right. Um, I will show you when we do it, right?
Yeah.
But in the question, they're asking you for two different sets of limits. So you should have two equations with limits. So let me show you. Um, for the first question, these are your answers. And you don't have to do any fancy working or anything. Just simply this. So they're asking you find the limit as x approaches zero. So think about it, right? If x gets smaller and smaller and smaller, 9 by that number would approach zero. So the answer is zero. Think of it, what is 9 by 1 over a million? And that will approach zero,
Yeah.
right? So you just write limit as x approaches zero for 9x. That is equal to zero. Um, for the other part, they would say limit as x. Think about it. If x approaching infinity, so just think about it. If x is a million, what's 9 by a million? If x approaches infinity, meaning that x getting bigger and bigger and bigger. If x is a billion, are we 9 billion, right?
Yeah.
So x getting smaller and bigger. I mean, why the function gonna get smaller or bigger?
Bigger.
Right. So when you take the limit for that function, it's supposed to end up with infinity. So that'll be equal to positive infinity. That's what the answer is supposed to look like.
Oh, alright. Yeah.
Okay, Alia, nah. Um, that's not it. You had to write it using limit notation.
Yeah, I just realized that, so I'm gonna fix it.
Yeah. And another thing, right? For question two, if you have 3 over 0, that answer would approach what? What would the answer approach? Think of it like one, like as x approaches 0, the
0?
fraction getting smaller and smaller and smaller.
Yeah.
So
Wait, so it won't be 0?
no. But I'm asking a question. How much zeros it could take to make 3? If you're saving $0 every day,
None.
none. But that's not exactly what we're looking at. We're doing limits here. We're looking at what happens right before the 0. So
Yeah.
it could give me a fraction that like real close to 0, meaning a very small fraction.
1 over 10?
No, that's so significant. Like if I have that'll be like 10 cents. That's still money. When I say smaller, I mean real small. Like it is almost like basically 0.
Like 0.1? Like 1 over.
No, I'm talking about like 1 over a billion or something. That's like 0.00000000001. That's what I'm talking about,
Okay.
right? That's basically 0. Now, if I put that into the function, remember what I was telling you. Imagine you were saving 1 over a billion every day. It would take you like 5 billion years or 3 billion years or something. So, and
Yeah.
that approaching infinity.
Yeah.
So, let me ask that question. If x approaches 0 for 3 over x, meaning that if we plug in values for x that's small, a real small, it like real close to zero, would our answer be big or small? Would it be big or small? 3 over a small fraction. It'd be a small number or a big number. If I take a small fraction, right? Like a very small fraction, and I put it into the function 3 over x.
Wouldn't
So
it could be small
no.
or big?
I want you to fully understand it, right? 3, let me just say 3 over 1 over 100. The fraction is probably confusing you. Let me look at decimals. 3 over 0.01. I think that'll be small or big?
That'll
3,
be big. That'll be big.
because and remember what I tell you, if you're saving 100s every day, it could take you plenty days to make up your 3, right?
Mm-hmm.
Or if you were saving less money, it would take more time.
Yeah.
So on a way to understand that, as you save less money, it takes longer to make 3, so it tends to infinity.
Mm-hmm.
The less amount of money you're saving, what does that mean?
The longer it could take you to save the amount you want to save.
And if the amount you're saving it approaching zero, it will eventually take you forever.
Yeah.
So that makes sense. Some of you okay with that? So what do you think the limit as x approaches zero, 3 over x will be?
Infinity.
Right. Be infinity. Okay, Amy, for question 2, you did x to infinity wrong. Think about it. If x gets, look at where the x is. The x is in the denominator. If x gets smaller, like, let me just say 3, let me start over 3 over 1. 3 over 1 is 3. Okay, let me look at 3 over 2. That's 1.5. Let me look at 3 over 3. That's 1. What about 3 over, let me just say about 3 over 10. That's 0.3. 3 over 100. That's 0.03. 0.003. What you notice going on there? What you noticing?
It
When,
gets
right. So if the denominator getting real big, what happens to your final answer?
it would be small.
Think about it like a half, right? A half is 0.5. A quarter is 0.25. And a quarter is less than a half.
Yeah.
Any number in the denominator is bigger for the a quarter. A
Wait,
half,
I can't.
so a half, right? A half is 1 over 2.
Mm-hmm.
A quarter is 1 over 4.
Mm-hmm.
Isn't the denominator bigger for the a quarter? Check it out. Isn't the number bigger? 4 is bigger than.
Oh,
Mm-hmm.
And if the denominator is bigger than the decimal itself is,
Small.
right, like 1/8. And 1/8 is smaller than a quarter and a half.
Yeah.
So if your denominator is approaching infinity, your final answer is going to approach what?
0.
Yeah.
Okay.
All right. So Nicholas, let me see where something here. Okay, Nicholas, you mix it up now. Hmm. So Nicholas, let me look at question two, right? Let me look at question two. You're saying that 3 over if the x value they're approaching zero, you say that the final answer will approach zero.
Yeah,
Let me think about that for a moment. And let me look at this example here. We had 5 over x. As the x value got bigger, what happened to the y value?
X value get bigger.
Wait, I said that wrong. I said that real wrong. Um, if x got if x got smaller, right? So we start off with 5 and we end up 1 over 1,000. So as x gets smaller, what happens to the y value?
Y getting bigger.
Right. So if you are approaching zero, you get if you're approaching zero, right? That means you're plugging in values that are smaller and smaller and smaller. And what we know happens when you put a small x value into a fraction. Check it out.
Y value getting bigger.
So that's supposed to be approaching what? Zero or infinity?
Which one? The Y value?
Um, yeah, the y value. The y value is supposed to be approaching zero or infinity. Zero or infinity.
Infinity.
Yeah. Because if the x value is getting smaller, it would think of it like this. It would take more days to make up the tree. And if you're saving close to $0 a day, it will take you forever to make $3, right?
Yeah.
So like it'll be infinity. And well, um, if you get if you get like an infinite amount of money, it could take you any days to make $3. Think about what I was just now saying. If you get an infinite amount of money, how much days it will take you to make $3?
Yeah, not infinite amount of money.
Yeah, you have an infinite amount of money. It could take you any days to make $3.
Now,
Nah, so that's supposed to be equal to zero. Because think of it from a mathematical standpoint. What is bigger? What is bigger, a half or a quarter? What is bigger, a half or a quarter?
uh,
Okay. What about a half versus 1 over 1,000?
half.
A half, right?
Yeah,
So as the denominator gets bigger, what happens to the final answer?
final answer getting smaller.
Right. So if x getting close to infinity, that fraction will get so small. Might as well just be zero. You understand?
Yeah, yeah.
Cool. Okay, Ali, you get there. Nice. Nice. So you all need to understand limits because when we doing this, it's not gonna be so straightforward. It's really not gonna be that straightforward. So let me just run through the answers. Nicholas, I want you to help me go through the answers, and I want you to explain the answers to me. So for the first question, why did I say my answer was zero? So as x approaches zero, why does that give us zero?
Because 9x, if x approaching zero, then um, you, how to explain this properly? X approaching zero, right? So X, well, it basically is zero. So 9 by 0 is 0.
Yeah, you can think of it like that. You can think of it like that. But like the limits way is that x getting so small, 9 by something that's very small is basically zero. Eh, Like imagine 9 multiplied by 1 over a billion. That'll just be like 0.00000000009. That's basically nothing, right?
Yeah.
Right? But at zero itself, it's just zero, like you said. And why is this one infinity? Why is this one infinity here?
X approaching infinity, so X is basically infinity. So 9 by infinity is positive.
Right. Makes sense. Second question. Um, right. Tell me.
Right, so X approaching 0 and is 3 over X. So if X approaching 0 and you divide in 3 by 0, 3 divided by 0, then first of all, 3 divided by 0, that's cannot really divide anything by 0.
No. But
Right,
we could look at right before.
right before 0.
Yeah, give me a fraction. Like when I say right before zero, it kind of don't make sense, but it makes sense at the same time. When I say right before zero, I'm talking about a fraction that's so small, it's basically zero. Give me a fraction that basically is zero.
1 over a million.
Right. Max, that question. If you put 1 over a million here, right? How much 1 over 1 million is it going to take to make 3?
3 million.
Yeah, and if like remember this thing approaching zero, so it will go even the fractions will go even smaller than that. So your answer is approaching what?
Approaching infinity.
Lovely. What about this one over here? If the denominator gets larger and larger and larger, that will make the fraction smaller or bigger.
You don't know. The fraction itself will be small.
Correct. Because you have a big denominator. If you have a big denominator, your fraction is small. Last one. Oh, Aliyah, you got the last one wrong, eh? Question three? Yeah.
Yeah, I was kind of confused about it, so I just like I didn't I
Let me,
didn't
let me show you how we could think about it, right? If
okay.
x, let me just think of x as being zero, right? Because that's what we're trying to look as we're trying to see what happens when x is zero. If x is zero, we're going to end up with
0.
no, we're going to end up with 9 all over 0 plus 2.
Oh, well, yeah. So it could be 9 over 2.
That's the answer. Yeah.
Oh, okay. Yeah, yeah, yeah.
Nicholas, how about you? You understand?
Yeah,
Cool. And what if okay, you think what if x was approaching infinity? Tell me about that.
9 over infinity.
Yeah, what's 9 over infinity?
Um,
What are we basically be? Like, tell me.
Basically it'll be zero.
Basically, that'll be zero. Yeah. That's it. How you feeling about limits?
Was kind of confusing, but
Okay-ish.
All right. Let me go like a speed run now. Speed run. Give like a bunch of random questions. What about like limit? And it don't just have to be X, it could be EHG, all kind of thing. So let me do that. Okay, somebody tell me fast. So a speed run. This is like a speed run. Wait, what are you correcting? Yeah. I'm gonna call upon random people. Nicholas, we have a function 3h squared. What would happen as h approaches zero?
when h approaches zero, it would be zero. Answer zero.
Yeah. Amy, um, I haven't seen if I got tired for this one. Tell me, what do you think the answer will be?
Um,
Listen, you're not sure.
no.
All right. So that brings me on to the next topic. Sometime in limits, you have to factorize first or simplify. And this is one of those questions. Before you can work this question out, you need to simplify it as much as you can. So that's a general rule in limits. So, Amy, is there any way I can simplify this limit?
Yeah,
How could I do that?
you could pull out on the numerator, you could pull out G.
Well, I wouldn't pull out G because it's just one term on top. I could I could cancel it off though, because I have G cube on top, which means G by G by G, and then I have G on the bottom. So I go end up with what?
3G squared.
That's correct. And is it easy now?
Yeah,
What I would be?
0.
Yep. Hmm. I'm thinking. Yeah, Leah. Tell me. How would this be?
Um, 0.
Yeah, that'll be zero. Because minus 3 over infinity, the
Is
fraction is so
yeah.
small. It's so small, it could just say it's infinity,
Is it yeah.
right? All right, Talia, help me with this one. In limits, I'll say it again, in limits, you're looking to see if you could simplify. Like you have to simplify first. Sometimes you don't have an option. You need to simplify first. Do you think this is a question where you have to simplify first?
Yeah.
Yeah, I think so. Rules for indices. So tell me, what are you seeing that I could simplify?
The A squared and the A to the power 5.
So tell me what to write.
9. Well,
Limits. So limits. Limit, yeah.
9. Wait, it'll be A to 0.
Say A approaching 0. So in limits, this reads as limit as A approaches 0. Limit as A approaches 0. Right. Tell me what
Um,
next to write.
it'll be 9 over A cube.
Right. And we can't really simplify that anymore. So what is the answer?
Um,
Let me see.
wait, I'm thinking. If
If-
it's 0, it would be positive infinity.
Yeah, it will be positive infinity because, I mean, if the denominator
Yeah.
is small, like we're going to put in numbers that small into the denominator. And if it's a small number, you go take plenty of it to make 9.
Mhm.
You understand what I'm saying? Not confusing here. Like, Tama.
No, I understand why. I
Because like
understand.
again, if you're saving a little bit of money, it will take you forever to save $9. So it basically forever infinity. Right. Nice guys. All you seem to be getting the hang of this. Let me spice up things a bit. Um, might be killing all the over here, but huh, I have faith. Think all you're all smart. Nicholas and you're all smart.
Nah, good. I not so smart.
Uh, a little devious over here, but it's for the improvements. You know, it's for the yeah, I believe all I can do is. So let me explain what to do, right? Let me explain what to do. Before you do anything, I want you to simplify this as much as possible. As much as possible. Like, and only then I want you to take limits. So look at this question for instance. In this question, we simplified it and then we take limits. So in this question, I want you all to expand, simplify, and if you have to factorize, do so. So give it a whirl. Oh, Aliyah, just asking you, what is x minus x? Tamalia, what is x minus x?
0.
Cool. Um,
So you remain with H.
yeah. So let's see how we can do this question. All right, so if you all could do this question, we could speed through the calculus part of it. Could speed through that. Oh, Aliyah, you see the sound system?
Yeah.
If you hear that singer, boy, hmm. I basically have like a cast car, like a car audio system in my room. Crazy.
Yeah.
Right? So I'm giving you all 10 minutes. I think that's too much time. 7 minutes, maybe. Take 7 minutes. See what I could do. Amy, like in this topic so far? You had to think.
Um, it's okay.
Well, I know everything has been easy for you,
Mm,
more or less. So I thought maybe this would have your brain juices flowing a little bit. Is it working?
yeah.
All right. So guys, I'll say one more time. In these kind of questions, you want to expand, simplify, and factorize if you can. All right, so down. Nicholas, any updates on what's going on?
Um, nah,
Is it that you didn't try to do anything or you
nah, getting through
all
slowly
right.
but surely.
So did you expand the x plus h squared?
No, but denominator are cancel off the x's and are going to try and simplify the numerator.
Okay, well before you can simplify, you gotta expand.
Expand the brackets.
Yeah,
Alright, yeah.
have to do that. Otherwise, you're not gonna go anywhere. Amy, did you expand the brackets?
Yeah.
Okay, cool. Did the x squareds cancel off?
Yeah.
Nice. So you remain with h.
With each other one? No.
H alone is a variable. The only variable.
Yeah. I remain with so far 2x each plus each.
All right. And that's good. That's good because okay, well you have x there. Let me check some out. Okay, yeah, it'll work out. It'll work out. Nice. All right. Amy, did you get through with the canceling? The factorization and canceling?
Um, No, I kind of stuck with like what I learned from before.
Tell me one more time what you had.
I had a 2x each plus each.
Ah,
Yeah.
hmm, hmm, hmm. You're there. You're right there, no, Amy. You're right there. You could do it. Read this.
Factorize.
How many you could factor out from these two terms?
E.
Yeah. And coincidentally, what does it have on the denominator?
1?
No, in the denominator it's supposed to have each.
No, I don't have that. Um,
In the denominator, x
yeah.
minus x is 0, so you end up with h.
I did cancel off the H. I should tell you what I have.
Yeah, something we have.
Right now, I have h squared plus 2hx over h.
Oh no, yeah, that's the correct thing, Nicholas. That's what you're supposed to have. That's what you're supposed to have. Um,
Think cancel the h and the denominator with the h squared.
okay, you're going real good. Real good. Amy, I feel you make a mistake somewhere. I think you made a mistake somewhere here. Like when you're expanding, you're supposed to end up with x squared and h squared and 2hx.
Yeah.
Okay, Amy,
Mm.
you make a rookie mistake. I'm a little disappointed. Can you cancel off when the top is being added or subtracted?
Okay.
It could only cancel off when it's written as a product.
My bad. Well,
Yeah. And Aaliyah, you've been awfully quiet.
Yeah,
Yeah, expand the brackets.
yeah, I get you with that.
All right. Send my
Wait,
picture we have so far.
what are you doing with the second bracket?
The second bracket.
Yeah, because I expand both. Well, no,
Okay.
I expand the first bracket and then
What
uh
you get when you expand the first bracket?
um x squared plus xh plus xh plus h squared.
All right. So you have how much? How much? You have how much? I would say hx.
Two
Hx is you have.
two hx.
Right. So x squared plus 2hx plus h squared. That's what you have.
Mm-hmm.
Good. Then right back the minus 3. Then when you expand the other bracket, what you get?
I had get minus 3x squared
Minus
plus
3x squared. How you get minus 3x squared? Is a minus sign here.
mm-hmm.
The minus 3 it doesn't have anything to do with this.
So it's just supposed to be so you're just supposed to yeah. So it could be minus x squared plus 3.
Yes. And then you see if
Okay.
anything can cancel off.
Okay.
H and the denominator, right? It could cancel off with h squared and 2hx or
Yeah, you would have to factor out the h term and then they can cancel off.
right, yeah.
Okay, Amy, you have the correct thing there. So you have 2xh plus h squared. Is there anything you could factor? Okay, I see some more working. All right. Yeah, that's correct. That's correct. Good. You have it. Nice. Right. And Amy, I want you to observe the answer you got right. You got 2x. Do you remember how to do differentiation from last class?
Yes.
All right. So if we differentiate this function, and the notation for this would be f prime x. If you differentiate x squared, where again? To differentiate, you pre-multiply and then you minus 1 from the power. So we end up with here.
Oh, 2x.
And if you differentiate a constant, you just get 0.
Yeah.
So you see,
Oh,
and same answer you get. Because what you just now did was the intuitive approach to differentiation. Um, that's the kind of common sense approach. I know it don't sound like common sense, but it's a when I explain the concept because it's kind of common sense, mathematical common sense,
mhm.
right?
Will you
But
get marks for that?
yeah, I know it disappointing, huh?
But what?
Yeah. Well, you know how to do the graph and thing, I just put the graph there for my YouTube channel. Like when I was explaining it to my YouTube channel, put the graph.
Mhm.
All right. So Nicholas, what was the final answer they got? Aliyah, what about you?
That's
A
an answer,
factor,
but I
a
get
factorize.
h plus 2x.
Right, and you find any limit as h approach 0. So if h is 0, we gonna remain with.
2x.
That's the answer. Aliyah, what about you?
And now factorize.
Okay.
So I remain with 2x plus h.
Right, and you find any limit as h approaches 0. So think of h as 0. We gonna remain with.
It could just be 2x.
Yeah, nice.
Okay.
Awesome. So now that you all understand that well, let me briefly explain. And in next class, we're going to just wrap up this and we're going to move on to something else in differentiation. So, Aliyah, I want you to give this a question and read.
Use the definition of the derivative as a limit to find f prime of x for the function f of x is equal to x squared minus 3.
Right. So, last class, what did I say what did I say the first derivative was? What was that again? And you differentiate, you're finding for the
The gradient,
right. And we also know the formula for gradient is y2 minus y1 over x2 minus x1. And do you know that?
yeah,
Right. And we also know that the gradient of a curve is different at all points. Amy, Nicholas, Alia. Let me know if I lose Alia. Alia,
mm,
Ah,
Amy, I lose you.
No.
Okay. So what we're going to do is we're going to take 2 points along the graph. Now, if I find the gradient here, right, guys? If I find that gradient, and this gradient is like well, Alia, I think it will be like the most accurate thing. Does that line up with the curve of the graph? Does that line up?
no,
No, but it kind of close, right?
yeah,
Okay, I'm gonna ask that question. If I bring the point over here now, does the line Tell me something. Does the line start to look like it aligning with the curve?
Yeah.
Okay, I want to keep that in mind. Amy, you seeing that? Watch that again. Does the line perfectly align with the curvature of the curve?
No.
Nicholas, does it perfectly align?
Nah.
Nah, so what we're doing here is we finding, if we were to do this, this would be a very rough estimate of the gradient of the curve there. But Nicholas, if I take this point and I bring this point like over here, uh, and I draw the line, does it line up with the curvature of the curve at that point, at that position?
Curve, no.
Yeah, watch it. Watch, check it out. It lining up it directly on top of it. Watch. If we wanted to find ingredient at this point, right? Then this line, it kind of aligning with the curve. You see what I'm talking about?
Oh, yes, you know.
Watch. But like if I do it over here, it would not exactly line up with the curve. But over here, it kind of getting closer, right?
Yeah.
What if I take the point and I move it even closer now? Hmm, what happened there? Would it line up even more?
Yeah.
Aliyah, is it lining up more?
Yeah.
Okay, and if it lining up more, ain't it in line with the curve?
Yeah.
Would I get a more accurate gradient?
Mm-hmm.
I would. Amy, you following?
Yeah.
So basically, the concept is we're gonna find a rough gradient of the curve. But what we also gonna do is we're gonna find the limit as the distance between these 2 points get to zero. Because Aliyah, when I take this point and I make it and I bring it closer, any gradient getting more accurate.
Yeah.
Okay, so if this point and that point on top of each other, enter that point, the gradient will be exact.
Yeah.
But what would be the distance? What would the distance between the 2 points be then? What would the distance be? If the 2 points on top of each other, what's the distance?
0.
Nicholas, you agree?
Well, it wouldn't have a distance.
And it will be
Yes.
so yeah, you're correct. Amy and Nicholas, the closer you bring the other point to this point, the gradient gets more accurate. So if I take the point and I overlap it, what is the distance between 2 points? Is there
Yeah.
any distance? Amy, is there any distance?
No.
No. So if we want to find the gradient of a curve, we take 2 points to find a rough gradient, and then we find the limits we find the limits as the distance between 2 points approaches zero. That's how it works. If anyhow you don't get out, let me know. Amy, you get out?
Yeah.
Okay, and now we need to figure out, well, how we gonna label our points? So the first point is x, and Nicholas, if my value is x, and I will put that into my function, I'll get f of x, right?
Yeah.
Okay, so my first coordinate is x and f of x. Aliyah, I move some distance each, so a some distance away from x. So tell me if you tell me if you understand why I'm calling this x plus h.
Yeah, because you want to find distance for there.
Yeah, let me explain. If this was five, right? And I tell you that this is two, that the distance from here to here is two. What is gonna be?
5 plus 2, which is
7.
7.
So if this is x and the distance is h, it'll be x plus h.
Yeah.
And if the x value is x plus h, and it will be f of x plus h.
Yeah.
Right. So we have the coordinates. You're gonna plug that into the formula for gradient. And you're gonna end up with this. At this level, I show you the concept. So I could come up with it in the exam if I forget. But I just had to memorize this. I just had to memorize that. F of x plus h minus f of x all over x plus h minus x. Heck, if all I want, all I even had to remember all that. All I could just remember this. F of x plus h minus f of x all
Over
over
H.
h, right? And you're gonna find the limits of that. So if you want to figure out the gradient, which is the first derivative, you're gonna take the limit of this. That's what you're gonna do. And well, you all know how to find limit. We just did it. Um, so Nicholas, you there?
Yeah.
So if I want to find the first derivative using this method, well, you understand, I have my 2 points, I use my gradient formula, and now I'm gonna find limits. Yeah. You okay?
Yeah.
All right. Cool. So next thing we had to do we have a function, guys? What's the function we had in this question? What's the function for the curve? Hmm. Anybody, what's the function for the curve?
F of x is x squared minus 3.
Right. And what are we saying the x value is here? What we're going to plug into the function here?
Is
So look at what's inside the bracket.
x plus h.
Right. So anywhere I see x, I'm going to write x plus h. So notice my function is x squared. So I wrote x plus h squared. You understand that?
Yeah.
And then I wrote, and it was minus f of x. So I wrote the x plus h squared minus 3 because that's f of x plus h. And then I said minus f of x. Aliyah, what is f of x? In this question, what is f of x?
The x squared minus 3.
Right. So Aliyah, from maths, you should know how to do this. This is functions. Whatever is inside the brackets, you're replacing that for x.
Yeah.
So I have x plus h. So I'm gonna write x plus h squared minus 3. That's what I write over here.
Yeah.
And well, minus f of x. F of x is x squared minus 3. Yeah. So and well, all I do is all I do that already. So that's it. Yeah. You just have to remember this. Amy, okay?
Yeah.
It was as bad as you think, or was like it's okay.
Nah, it was okay.
All right, nice. Well, that's it for class today. We finished exactly on time. Let's go. Next class, we'll do some questions. We'll do some questions on this. And we'll move on to something new. I want to move on to product rule, quotient rule, and chain rule. Nicholas, you should remember those things. Those things are especially chain rule, you know?
Chilling to my mind.
Yeah. Aliyah, you should also remember those things that you did in school. Product
Yeah.
rule, quotient
Yeah.
rule, kind of thing. Well, all right, guys. See you all here next Saturday. Right? Amy, I'll see you tomorrow, 10 to 12, right?
Yeah.
All right, nice. Well, it's everybody. Enjoy the rest of your Saturday.
Yeah, later you too.
Bye.
It's